So this section is chapter 5.1, Rules for Exponents. So if you take a look, I'm actually on page 311. And so if we look at a typical problem like 5 multiplied by 5 multiplied by 5, which gives us 125, okay, we can shorten this so that it wouldn't be so much work to write all this. We could write it as 5 to the power of 3, which is still going to be equal to 125. So this is a shorter way of writing 5 times 5 times 5. And so we need to know that the 5 is what we call the base, and the 3 is called the exponent. Okay, so that's the exponent, and it describes what this means by 5 times 5 times 5. So some examples would be, 2 multiplied by 2 multiplied by 2, which is really 2 to the third, which gives us an answer of 8. So the base for this one is 2, and the exponent is 3. So we could have another one like 6 times 6 times 6 times 6, 4 times, right? And so that's really 6 to the fourth. So the base is 6 and the exponent is 4. We could also do 7, which is really 7 to the 1. So the base again is 7 and the exponent is 1. We can do decimals too. It doesn't make any difference. So 0.5 multiplied by 0.5 is really 0.5 to the second power. And so again, the base is 0.5 and the exponent is 2. And we can do variables too. We can go x multiply x multiply x multiply x multiply x, where that's just going to be x to the fifth. Because x's are variables, and the variables are numbers that we just don't know what they are yet. So again, the base is x, and then the exponent is 5. So again, it's just another way of looking at that. And of course, now we have to be more aware of this as we do the order of operations for some of our equations. So let's take a look at some setups. Let's say we're evaluating exponent expressions. Let's say you have 1 plus, and that's 2 to the fourth over 4. Okay, so we want to evaluate it or simplify it. So again, we have 1. 2 to the fourth is really 2 times 2 times 2 times 2. And 2 times 2 is 4. And 2 times 2 is 4. And then 4 times 4 is 16. So this now becomes 16 over 4. And then we can do the division here. 16 divided by 4 is 4. And so our final result is 5. So that's another way of seeing a problem. Another example would be something like 3 times 1/3 to the second. So that's really saying that I have 2 1/3s. So that's 3 times 1/3 times 1/3. And this is 3 over 1. So if I want, I can multiply or I can divide, which turns into 1. And 1 multiplied by 1/3 is just 1/3. Another example would be maybe negative 2 to the fourth. This one always throws people because this is really saying negative multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. And so because there's no parentheses, this 4 is only going to the 2. It is not being affected by the negative sign. So in essence, this becomes negative 16. Because 2 times 2 is 4, times 8 times 2 is 16. Okay? But if we do something like this, negative 2 to the third, that means again the same thing. So I still get negative and it's 8. But if I do parentheses, then we have a different situation, because now the negative is being set up to be 3 times. So that's negative 2 times negative 2 times negative 2. And negative times negative is positive. And then a positive times a negative makes it negative 8. So again, if we go back to negative 2 parentheses to the 4s, we see that we get a different result. So a negative times a negative is positive, times a negative is negative, times a negative is positive. So this turns out to be positive 16, where back here we got negative 16. So you have to be really careful when you see stuff like this, that you need to pay attention to the parentheses, because if there are some, then it is including whatever sign. But if it doesn't have it, it's not going to include it. And so that's pretty important to see that. Okay?